Okay, as promised, this is the video where you're going to see some of the computer work. So if you were to see what's in front of me right now, I have, looks like 7 cuvettes in my little cuvette holder that are already filled and ready to go. So off screen, my 5 solutions that I made up for my calibration curve, I have those sitting in a nice little row. I have one cuvette that's ready to go as my background, and I'm going to get that going right now. So, oops, I'm still in QuickTime there. So remember, every time you turn this thing on, you're going to have to take a fresh background. So we're going to do that really quickly. I still have already let this warm up just so that we are not waiting on it here. But the 7th cuvette that I was mentioning that I have, so the 5 samples, the 1 background, and then I already preloaded my Gatorade. So pure Gatorade, remember that was the goal, is to know what concentration of the blue dye number 1 is in this Gatorade. So I preloaded one that is pure Gatorade. And the reason why I chose the blue one is so that we can keep track of this little step that's going to happen to us where we are going to find out that my blue Gatorade is going to have an absorbance higher than 1. We'll see that in a moment here. All right, so anyways, finish my calibration curve. Before I had mentioned to you that we're going to have our 0, 0 on our calibration curve, so 0 concentration of the dye, and we should get 0 absorbance. So I just did the background with this sample that is pure just DI water, and then I'm going to hit play, and this is kind of what I mean. You should be able to see that it's as it should be. It's saying the absorbance relative to the background is effectively 0. You can see a little bit of an insight into the noise here. Okay, I'm scrolling down. Remember, I wanted to do all of my work at 630.3. So I have a little bit of some noise floating here. That's to be expected. But actually, this gives me a nice little indication that this thing floats around in that thousandths place for the absorbance. All right, I'm just now removing it. You should see it go a little haywire. I'm picking up my lowest concentration. I'm wiping down the cuvette, and I am tapping it to get rid of any bubbles, and I'm putting it in. All right, I'm going to stop the data collection, and let's just say save as cal1. All right, cal1 today happens to be November 20th. Yeah, I'll just throw that on my desktop. So that 1 is going to represent how many parts. So that's how I'm keeping track of this. Remember, you should be doing your calculations on the side here. All right, so let's start this again. So erase the last data, that's fine because I just saved it. And I'm going to make you guys look them all up here. Although that's a little rude. Let me, I don't know how well you're going to be able to see this. So this is still the last one that was in there. I'm gonna give you the files, but I'm also gonna let you see where it's at. So there's 630.3. Okay, you can see the absorbance. I don't know if you can read that on your screen. It's 0.121. Okay, that was still the first calibration. All right, so out with that one, in with the new one. This is the one that had 2 milliliters of my working stock. Okay, you can see that there. I'm going to stop it, save it. Okay. Again, out with the old. When I was grabbing all my cuvettes, I happened to notice that I had multiple cuvettes, like different manufacturers. I had different brands of these little plastic cuvettes. And that is important. I needed to make sure that I had. So here's your new one. Okay, this was 3 milliliters of the working stock. But if I had different brands, different manufacturers making my cuvettes, and I'm using them all in the same experiment, you never know. That could contribute here. Save as. This one was 3. Notice these have all so far been under 1 absorbance unit. That was all due to that planning work that we did. Okay, that was the 3rd sample. This one is the 4th sample, but it's going to get the label of 5 for me because I am labeling not based on the number of the sample, but based on the milliliters of working stock that was added. All right, you can see this one's jumping up here. We'll scroll down if we're just trying to read it off the screen. Where did it? There it is. This one is 0.685. Stop it. So again, I'm not going to call that 4. This is going to be 5. Okay, this is going to be the last of my calibration curve. You hear me tapping it because I saw a little bubble there. Okay, you remember I did that pre-work to try to get something a little less than 1. And looked like that worked out pretty well for me, so I'm happy with how that turned out. If it had been a tiny bit above 1, I probably would still use it. What I would do is I would graph up my calibration curve and see if I had any reason to believe that it was falling off of linearity. But so this is 0.953. This was the 7 parts. Okay. All right, so this is how good my calibration is my calibration curve right now is good up until I get right around 1. Because that was the highest one that I'm going to use here. So I'm about to put in, this is different now that I'm putting in. I want you to think about what we're doing with the calibration curve. We are using known concentrations of dye. Remember, I made everything associated with my calibration curve. I'm using known concentrations of dye and I'm measuring the absorbance to get the data. Then what I'm doing now, this is the pure Gatorade. So what I have now is I have pure Gatorade that I have no idea what the concentration is. So I'm going to measure the absorbance here and compare it against the ones that I just did. And that's going to help me understand what the concentration must be. But this is intentional to have picked selected a Gatorade that you see the absorbance is over 1. So my calibration curve is only going to be good between 0 and 1. So right now my sample is too concentrated. And if I really want to get in the world of linearity, what I need to do is I need to now dilute my sample. Okay? I just needed to get less than 1. This is, I can tell because think of all the data that I have. This is more concentrated than my working stock. My working stock was delivering before, pure working stock was delivering something like a 1.3. So I pre-grabbed, and you're not going to be able to see me doing this, but I think you've seen enough to know what's going on. I pre-grabbed another one of those little 10 milliliter characters, my volumetric flasks. And what I'm doing right now as I'm talking, but you can't see it, is I'm going to put some number of squirts of Gatorade into this, and I'm going to dilute it. I'm worried because, again, it's nonlinear in this range. I'm worried that if I were to just dilute it by a factor of 2, so 5 squirts of Gatorade, 5 of DI water, that I would not necessarily cut my absorbance in half. Because remember, it's nonlinear up there, and you start to get those diminishing returns. So I'm being extra cautious. I only put in 3 squirts, and you need to know that if you're going to be able to accurately take into account what's going on. So I have my Gatorade. I just finished filling the water into it. So this is now 3 parts Gatorade into a tin. I'm stirring it with my little my pipette right now. I'm grabbing a brand new fresh cuvette, and I'm filling my cuvette. Sorry to be giving you the narrative of what I'm doing. Feels like it's better video than just staring at this rainbow on the screen. Okay, so I have filled the cuvette, making sure I'm holding it on the frosted side. Tap, 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 get rid of any bubbles, wiping it down with a Chem wipe, and putting it in. All right. So this is fine, right? I would have been happy with anything that's in like this range here. Would have been great. It falls within my calibration curve. So 3 parts Gatorade into tin. I still need to be looking at my, where did it go? Right here, 0.472. All right, save as, how do I want to call this? I'm going to call this 30% Gatorade. And if you're following what I'm saying by that, that is 3 parts Gatorade into 10, right? 30% Gatorade. Okay, we now have all of our data. So the next thing that you need to do is you need to construct a calibration curve. You need to fit the calibration curve with a linear regression. You need to pull that information. You need to make sure that you're actually in concentration on the x-axis and using absorbance at 630.3 on the y-axis. And you should have enough to figure out what the concentration of that Gatorade, or what the dye is in the Gatorade at this point. So I might do one more wrap-up video that shows you the answers that I'm getting, that maybe I'll withhold that until after you're done. I don't know, but I think we're good for this video. All right, thanks all.